Welcome back, focused learners. We've got a seriously fascinating explainer lined up for you today. We are going to be breaking down a highly complex, cutting-edge document, the ACS version 1.5 Research Program Status Report. So, if you've ever found yourself wondering how physicists, and mathematicians for that matter, are trying to basically decode the fundamental operating system of our universe, well, you are exactly in the right place. We're going to look at the hard data, the brilliant successes, and honestly, the spectacular failures of this proposed framework for quantum gravity.
Here's a quick look at our syllabus for this explainer, just to ease the cognitive load a bit before we get into the heavy physics. We'll start with a new view of spacetime, move on to the AI testing ensemble, review the big successes like shrinking dimensions, confront the failures regarding hydrogen and flavors, and finally, we'll wrap the whole thing up by grading the theory.
Okay, let's dive into this. Section 1, a new view of spacetime. What exactly is ACS?
So the theory is called Adaptive Computational Spacetime, or ACS for short, and the central concept here revolves around post-sets, partially ordered sets. The absolute easiest way to think about this is by using a digital zoom analogy. You know when you look at a super high-res photo on your phone? It looks perfectly smooth, right? But if you just keep zooming in, eventually that smooth image shatters into these discrete, chunky, blocky pixels. Well, ACS proposes that the universe works exactly the same way. Down at the absolute deepest ultraviolet quantum level, the Planck floor, there is no smooth continuous background manifold. Spacetime is literally just a network of chunky computational events bound together by strict causal links. It's a completely geometry-free, highly discrete starting point.
Now, the single most encouraging thing to come out of the external assessment is this. ACS is actually starting to behave like a falsifiable research program, rather than just a collection of cool, interesting ideas. And that highlights a pretty profound truth about how real science operates. I mean, a beautiful idea is kind of useless if you can't test it and potentially prove it wrong, right? The true value of the ACS framework, which the independent review absolutely nailed, is its radical transparency. It gives us hard, numerical predictions that can be mathematically verified or, definitively broken.
Moving right along to Section 2, the AI testing ensemble. Let's talk about how you actually audit spacetime.
Now, this wasn't just a bunch of physicists huddled around a chalkboard checking each other's math. No way. This was a massive multi-model convergence experiment. They used 4 distinct AI architectures to blindly test the physics, completely removing human bias. Meta handled the coordination and pre-registration of the tests. Grok was brought in as the adversarial auditor, basically actively trying to break things and acting as a kill switch. Gemini functioned as the physics-forward model, actually running the posit simulations and generating mock light cones, and Copilot managed the reproducible pipeline, so all that data was perfectly harmonized. And just to be super clear here, this had absolutely nothing to do with AI consciousness. It was entirely about using these models as a totally unbiased, incredibly strict investigative team, searching specifically for low-entropy mathematical structures in the data.
Section 3. Successes. Shrinking dimensions. Time to look at some validated triumphs.
2.027. This number. This represents the strongest, most genuinely mind-bending, validated discovery in the entire report. So we experience the macroscopic universe in 4 dimensions, obviously. But the ACS framework successfully computed that if you trace the spectral dimension all the way down to that quantum ultraviolet limit we just talked about, the effective dimensionality of the universe actually shrinks. It flows smoothly from 4D down to exactly 2.027. This is a massive win. It mathematically bridges our large-scale reality with that chunky, discrete pixel level of the quantum realm, and it actually matches constraints from other advanced quantum gravity theories.
And this brilliantly illustrates just how stable that finding actually is. Because in computational physics, you have to prove that your results don't just, magically vanish the second you make your simulation larger. So the ensemble doubled the size of the simulated network from 1,000 nodes to 2,000 nodes. And guess what? The dimensional reduction didn't just survive, it barely budged, shifting by a microscopic delta of just 0.027. This mathematical bridge isn't some random fluke. It's incredibly stable, it's verifiable, and it actively connects the microscopic geometry straight to our macroscopic world.
Plus, this data supports another major physical phenomenon, a Hagedorn-like thermodynamic transition. Think of it as a critical boiling point for the universe itself. When they scaled up from 1,000 to 2,000 nodes, the specific heat capacity proxy, which is labeled Cmax, scaled up by a huge factor of 2.4 times, jumping from 0.395 to 0.950. Now, the external review rightly points out that this is consistent evidence rather than definitive proof. They're going to need much larger network sizes to be 100% sure. But a 2.4x scaling jump, that is exactly the footprint you'd expect to see if the universe's foundational network is going through a distinct thermodynamic phase change.
All right, Section 4, Failures, Hydrogen and Flavor. Let's pivot to the friction and look at the structural blockers.
So the first massive failure is the basic atomic hydrogen test. To reproduce the standard Coulomb force, the basic 1/r force that literally allows atoms to exist, the mathematical framework strictly requires a delta value of exactly 1. But reality shows the ACS framework produces a delta of 0.218. So simply put, the theory cannot currently build a working hydrogen atom. The AI audit flagged this as a critical, incomplete structural blocker. You can't just slap a patch on this. The framework needs to organically derive a totally new two-scale mechanism, or, well, it entirely fails at explaining atomic physics.
And hey, if you thought the hydrogen problem was bad, let's take a look at the flavor C9 block. Here, the framework attempted to derive the mass scale using an S3 leptoquark ansatz, which is basically a highly specific, very educated theoretical guess. The expectation was this tightly derived mathematical mass scale. The reality? It missed the mark by 20 orders of magnitude. 20. Let's just pause for a second to appreciate the sheer, ridiculous scale of that failure. That is literally like aiming a laser pointer at a basketball hoop in your driveway and somehow hitting a completely different galaxy. It is fundamentally missing the underlying mechanism.
But here is exactly why this explainer matters and what you should really take away from all this data. The only reason we even have these insights is because of the program's radical transparency. They explicitly and without any hesitation whatsoever separate their hard, validated mathematical wins, like the dimensional reduction we talked about, from their massive conjectural failures, like the hydrogen and flavor blockers. In theoretical physics, hiding the flaws in your math behind a wall of complex jargon, it's incredibly easy to do. Clearly and publicly labeling your 20 order of magnitude failures, that takes supreme scientific integrity.
Which brings us to Section 5, Grading the Theory, the Final Assessment.
So, the crucial point is captured perfectly in this final report card. If we look at its ultimate goal, trying to be a complete theory of everything, ACS gets a C-. I mean, you simply cannot be a theory of everything if you can't even construct a working hydrogen atom, right? But regarding its scientific integrity, it scored a solid A in internal honesty and an A- in separating results from conjecture. Because of this radical transparency and its strictly falsifiable numerical pipeline, its grade as an overall research program is totally rescued, landing at a very respectable B+. It fails at being a complete theory, for sure, but it spectacularly succeeds at being rigorous, honest science.
Which leaves us with this final, lingering question. Is a beautifully falsifiable failure actually worth more to science than an untestable, perfect theory? The ACS framework might be fundamentally broken in certain places, but because it's broken right out in the open, we can actually study it, test it, and learn from it. And honestly, that is the true gold standard of physics. Thank you so much for joining me for this Explainer Focused Learners. Keep questioning, keep visualizing the data, and I'll catch you on the next one.